30-kilogram child moving at 4.0 meters per second jumps on a 50-kilogram sled that is initially at rest on a long, frictionless, horizontal sheet of ice. Part A asks us to determine the speed of the child sled system after the child jumps on the sled. First, we can write that m1 v1 is equal to m1 plus m2, which is the total mass, times the final velocity. So we're trying to solve for v final. So to isolate v final, we see that v final is equal to m1 v1 divided by the total mass, which is m1 plus m2. And now by plugging in, we can plug in our values. And we solve that the final velocity is equal to 1.5 meters per second. Part B asks us to determine the kinetic energy of the child sled system after the child jumps on the sled. So we know that KE, kinetic energy, is equal to 1/2 mv squared. And now we could simply plug in the values that we know. It's equal to 1/2 times the total mass, which is 80 kilograms, times 1.5 squared, which we found from part A. And by multiplying, we find that the kinetic energy is equal to approximately 90 joules. Part C asks us to determine the speed of the sled right after the child jumps off of it. So in this case, we are finding the velocity directly after the child jumps off the sled. So we can write m1 plus m2 times v, which is the total mass times velocity, is equal to m2 v2. Instead of, like the part A, we had m1 v1, now we're doing m2 v2. And now to isolate v2, we can write v2 is equal to m1 plus m2 times v divided by m2. Oops, sorry. And now we can plug in our values. So we know the total mass is equal to 80 kilograms times the velocity, 1.5, all divided by mass 2, which is 50. And by solving for this, we find that velocity 2, right when the speed of sled right after the child jumps off, is approximately equal to 2.4 meters per second. Part D asks us to determine the kinetic energy of the child sled system when the child is at rest on the ice. So basically it's asking us to find the kinetic energy when the child jumps off the sled and is not on the sled anymore. So we can write kinetic energy is equal to 1/2 mv squared, which is really, it's 1/2 m2 v2 squared. And now we could simply plug in our values. So KE is equal to m2, which is 50, times velocity 2 squared, which we found in the previous part, which is 2.4 squared. And by multiplying, we find that kinetic energy is equal to about 144 joules. Finally, part E says, compare the kinetic energies from part B and part D. If the energy is greater in D than B, where did the increase come from? Or if the energy is less than in D than B, where did the energy go? So looking back, kinetic energy from part B was 90 joules. And then from part D, kinetic energy was 144 joules. So as we can see, there was an increase in kinetic energy from part B to part D. So since there was an increase, where did this increase come from? Well, since the child decelerated the sled in order to stop, he ended up adding work to the sled to stop it, because work must be done to change the speed of the sled. And since he added work, and work is a change in energy, the energy of the sled was actually increased, even though it was negative work to stop in order, because it was slowing down. Since work was done to the sled, energy was increased.